G'day guys, we've got a calculus question today which is basically an introduction to related rates, where the question tells us that the length of a side of a square is increasing at a rate of 0.01 centimeters per second. We've got to find the rate at which the area of the square is increasing when the side length is 8 centimeters. So what I've done is I've drawn a square here for you guys, and we're going to denote each of these sides x. So this side here is going to be x, and because it's a square, this side here is also going to be equal to x. And we've got to find the rate at which the area of the square is increasing when the side length is 8 centimeters. Okay, so the rate at which the area of the square is increasing is going to be denoted dA, the change in area, with respect to the change in time. Cool. And what have we been given? We've been given the change in the side length here. So we've been given dx dt. Okay, so what we're going to do next is we're going to use the product of this and another derivative that will equal the change in area with respect to the change in time. So what we've got here, guys, is we've got a particular derivative multiplied by dx dt is going to have to be equal to dA dt. So because we don't have a dx in the answer, obviously we're going to have a dx in the denominator, so they will cancel out. And because we don't yet have a dA, this is going to have to be in the numerator, dA dx. So that's a good way of, like a good thought process, of figuring out what our two derivatives are going to have to be to form our final derivative. So from here, guys, what we're going to do is we're going to get a formula which links a and x together. So let's go and do that. So we know that the area of a square, well, hopefully you guys are aware that the area of a square is equal to just the side length squared. So from here, we can say that the change in area, or dA dx, is just going to be simply 2x. So what we get, guys, when we substitute all of the information that we have been given into the formula, we get the change in area with respect to time is equal to dA dx, which is 2x, multiplied by the change in side length with respect to time, which is 0.01. Cool. So what we do is we've been told to evaluate this change in area with respect to the change in side length when the side length is 8 centimeters. So this is when x is equal to 8. So we can substitute that into our formula, and we have dA dt is going to be equal to 2 times 8 times 0.01, which gives us a final answer of 0.16 centimeters squared per second. So guys, this is a relatively simple related rates question. What I've done is I've first of all written down all of the information that is contained within the question, and then I've used this information to deduce what my related rates formula is going to be. Once I've got that, what I can then do is I can hopefully use my mathematical intuition to figure out what each of these relationships are, sub them into the equation, sub in the relevant times or lengths, and then my answer will then pop straight out. So I hope this question helps with a sort of an introduction to related rates. A lot of the problems online or on YouTube are more advanced ones. I've just thought I would just put together a very, very basic one for you guys as a sort of a starter. So I hope it helped. If it did, give it a thumbs up. If you have any questions with regards to related rates, don't hesitate to leave them in the comments section below. But until next time, guys, the only way you're going to get better at these is practice. So again, like I say in most of my videos, practice, practice, practice. If you bang your head against the wall enough times, eventually it will fall down. But until next time, guys, just keep enjoying your maths. And I'll see you soon.